Alright, so we're going to do problem 11. Problem 11, I didn't write it out, but what you have is a car that's 1,500 kilogram car. And it's going at an initial velocity of 10 meters per second. Alright, and so it goes like this. It's on a hill that goes to a valley, then it comes up here like this. And they give you the heights here from the bottom of the valley. This is 10 meters. And this height over here is 15 meters. And this is a gas station. Alright, so the car, which is over here, runs out of gas. When it's right there with this initial velocity, the driver puts it in neutral. And what we're trying to find is what's the car's speed when it gets to the gas station up here. So we want to find the velocity when it gets up here. Alright, so this is a typical energy problem. We're going to do these like we do all of them. Energy initial equals energy final. And then we have to look at the situation. So in this case, the initial energy, we're going to call the lowest point down here gravitational potential equal to 0 at the lowest point. So it's above the 0 point, so it does have gravitational potential. So we're going to call this mgh1. This is h1 over here. This is h2 over here, so we don't get them confused. Okay. Plus it has a velocity, so it has kinetic energy to begin with. So we have 1/2 mv initial squared over here. Then the final velocity we're going to do at this point here, when it's at the gas station, and it went to this position, is not at 0, so it does have gravitational potential. This becomes mgh2 plus 1/2 mv final squared. Okay? And what we're solving for is v final. That's what we want to get. Okay, so now it just becomes a lot of algebra. So to solve this, we're going to, first I'm going to divide everything by m. Divide both sides by m. Because the nice thing about that is the m's all go away. Okay, because there's an m in every term. Okay, and then I'm going to end up with gh1 plus 1/2 v initial squared is equal to gh2 plus 1/2 v final squared. Okay, then I'm going to move gh2 to this side, so it's going to become negative. So I'm going to have gh1 minus gh2 plus 1/2 v initial squared is equal to 1/2 v final squared. And then I'm going to multiply by 2 and take the square root. So I'm going to get the v final is equal to 2 times the quantity gh1 minus gh2 plus 1/2 v initial squared, all that under the square root. But I have all that. So now I can just plug that in and say, oh, well, this is the square root of 2 times 9.8 times 10 minus 9.8 times 15 plus 1/2 of 10 squared. And that's 2 multiplies the whole thing there. And you do that, you get that the final velocity is 1.4 meters per second. Okay? Pretty basic one, not that hard to do. Alright, I'm going to do another one on this same video, so I'm going to do number 22. Okay? 22, the problem states that we have a situation where we have a wall with a spring and a mass connected to the spring. Okay? And we have, that's case part A, and in case part B, we have the same mass, but now it's connected to 2 springs in this case. So this is the mass, this is the mass. Alright, and so what we're going to do is we're going to compress the springs, so that's going to be compressed by delta x. In both cases, it's going to be compressed by the same amount. And then we're going to let go of it, and we want to find out what the velocity of the block is. So it gets compressed and the spring is released, and we want to know how fast the block is moving. And we want to compare that, this case to this case. So to do this, we're going to say, okay, energy initial equals energy final. In this case, the initial energy, because it's not going up or down, there's no gravitational potential. The block starts with no kinetic energy because its initial velocity is 0. All the energy it's starting with is spring potential. This x is the distance from the relaxed position. Remember, we talked about springs in chapter 9. The final is going to be all kinetic energy. Okay? And so we want to figure out what the velocity is here and compare it to the velocity here and see how they compare. So we're going to multiply by 2 and the 1/2s go away. Okay? Then we're going to get with kx squared. We're going to divide by m, so kx squared over m is equal to v squared, or v equals the square root of kx squared over m. Okay? Very simple problem. Or we can pull the x squared out. We could write this as v is equal to x times the square root of k over m. Okay? Now, in this case, case 2, we still have energy initial equals energy final. But now we have 1/2 kx squared for one spring, plus 1/2 kx squared for the other spring, and they told us the springs are exactly the same, so the k's are exactly the same. And then it's going to equal to your final velocity, or your final kinetic energy, which is 1/2 mv squared. So you add these together, and 1/2 plus 1/2 is just equal to 1, so this becomes kx squared is equal to 1/2 mv squared. You multiply by 2, and you get 2kx squared is equal to mv squared, or v squared is equal to 2kx squared divided by m. Then we take the square root of that, so this is v is equal to the square root of 2kx squared over m. The x squared can come out of the square root, and we get x times the square root of 2k over m. Or what's the difference here? Well, you have 2 springs instead of 1 spring, but your velocity is not twice as big. It's only the square root of 2 times as big, or about 1.4 times as big. So you don't get double the energy or double the velocity coming out. Okay? You only get square root of 2 times that because of the squared. Alright, so those are the answers here. Or what we could say is, I'm going to rewrite this. So this is the velocity in part A, this is velocity in part B. If we want to compare these directly, I can say that, oh, well, velocity in part B is equal to x times the square root of 2 times the square root of k over m. Right, I just pulled the square root of 2 out, which I can do because it would be underneath. But then I can say, oh, but this is just equal to the square root of 2 times x square root of k over m. But xk over times the square root of k over m, that's exactly equal to VA. So velocity of B is just equal to the square root of 2 times the velocity of A. So that's your answer. Increases by the square root of 2. Alright, that was problems 11 and 22.